Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will discuss with Descriptive Econometrics, and that too we have already discussed Descriptive Econometrics with univariate structure and bivariate structure. More specifically, we have discussed some of the econometrics output with respect to central tendency, dispersions, spreadness, and then the kind of bivariate econometrics like covariance and correlation. Then ultimately we may get some kind of intermediate output with the help of these variables and data to report like mean, variance, standard deviation, correlations, covariance, all these we can have. That will somehow address some extent the engineering problem, but ultimately the econometrics requirement is to test the particular outcomes and validate before you use for any kind of particular requirement. But ultimately for that we need to know the procedures through which you can actually check the statistical reliability. And for that few things are very much essential. Of course, the basic steps and structure which I have already highlighted in the last lecture. And in order to understand beta structures, means the kind of selection of the particular model and the selection of a particular technical tools. So we should know more about something, and that to the umbrella of inferential econometrics. So here we will be dealing with two things. One is the understanding of the probability and probability distributions. Another one is the sampling and sampling distributions, because probability is one of the basic infrastructure in the engineering econometrics. Any kind of testing, empirical testing, so you need to use the probability level of significance. So knowing the details about the probability and the probability distributions will be very helpful to analyze the problem in a much attractive way or in a much better way. So let us see what is exactly the probability concept and what are these probability distributions. Sometimes here regression modeling will follow with a particular distribution only. If the data is showing a particular distribution, so then the model can be designed accordingly. Until unless you know the pattern of the data and the kind of structure, so that means we need a complete visualization. So after knowing the visualizations, you like to actually check how these data are all about, and then what kind of distribution they follow. So accordingly you can pick up that distribution or pick up that particular functional form to address or to analyze the problem, and obviously that will give you better inference and better insights as per your requirement. So ultimately, so we should like to know something about the probability structure. So probability as usual very simple, and the subject in the case of engineering econometrics, what I have already mentioned, this is actually basic infrastructure, and it is you to understand, and you get to be acquainted. And what is exactly probability, what are the probability distributions, what are the probability rules, and how is the how you have to interpret, and the kind of decision making process with respect to different kind of situations. And some of the basic items are connected with the probability theory, like random variables, discrete series, continuous series, discrete random variable, continuous random variable. So these are things actually you are supposed to know. Of course, you have to just understand and know these things. And so far as the calculation is concerned, reporting is concerned, you can directly use the software, and again Excel spreadsheet will help you a lot to get all these details. And then in a standard or advanced statistical software or economic softwares further will add value to do your processing. So ultimately these are all your learning objectives, and probability simply actually the likelihood that an outcome occurs, and it is a kind of experimental process, and we have a outcome, and that is with respect to a particular experiment. For instance, if we toss a coin, and what are the possible outcomes, and what is the total outcomes altogether. For instance, if you are tossing a coin, then it will be either head or tail. So that means the sample space will be either head or tail. So when you are tossing, so it may appear the head or it may appear the tail. Ultimately, that is the only alternatives. So that means this is a simple example. So the complex examples depends upon how is the game all about. For instance, the same coin can be transferred into complex mode when you have two different coins and tossing simultaneously. In that times, so you will have your bigger sample space. Like in the first case, you have only two sample points, head and tail. So now having two coins simultaneously, so your sample space will be again high. For instance, it may be the appearance of head, tail, head, tails, and tail. So 4 appearance will be there. Again, so three coins can be tossed simultaneously. Then the sample space again will be increased. So that means it's a kind of a process of generalization, and this is how you have to understand the system, understand the tricks, the statistical rules, econometrics rules, because they are basics actually. Unless you understand all these basics, so you cannot play the game in a better way. So you must be acquainted. So you have to understand and you have to connect as per the particular requirement. Okay, so event is a particular item in the sample space, and so the examples which I have already given is a kind of problems which you can actually analyze through probability. For instance, suppose one coin you are tossing, so how is the kind of output and how you have to interpret the kind of output. The concept in the earlier lecture we have discussed the concept called as correlation, so which is actually between -1 to 1, very standardized, and as a result you have a very standard kind of interpretations as far as inference is concerned, the kind of strategy application is concerned. So a probability is also similar kind of framework. So the range of the probability will be always 0 to 1, and when it is 1, it's a kind of perfectly, there is no difference between predicted and the kind of happenings. But in the case of 0, so there is no kind of happening, and in between you have to find out more occurrence and a high occurrence, something like that. And so the two extreme points are 0 and 1. Most of the instances it will be appearing in between, and the total probability will be exactly equal to 1. For instance, if you are tossing a coin, so there are two sample points, either head or tail. So obviously it is the 2. So that means what will you do actually, we have already discussed with variables information, then frequency, cumulative frequency. So the cumulative frequency will give you the total sampling. So now with the total sampling, if you divide with the individual sampling, then that will give you the probability value. It's a simple kind of a structure how you have to transfer the concept into a probability format. In fact, sometimes we can use the probability as a normalization tool. So to normalize the data and then use as per your modeling requirement. So ultimately in these examples, head and tail, so total is 2. So what will you do? 1/2 for head and 1/2 for tail. So that means for individual event, so the probability will be 1/2, that's 0.5. Again it is for tail it is 1/2, 0.5. Then if you sum these two, again the total probability will be equal to 1. So that means the so far as the rule is concerned or the structure of probability is concerned, it's very standard. In a particular event, the probability of a particular event will be in between 0 to 1, and what all probability if you add, probability of all events if you add, then it will give you actually 1. So that means total probability is always equal to 1, and individual probability event specific is always between 0 to 1. That means compared to correlations, so the probability value cannot be negative, so it will be always in the positive sides, because it's a kind of an expectation. Nobody will really go for negative kind of things. So this is the basics about the probability, and there are various theories behind probability, so we are not going in details. In fact, I have another subject NPTEL subject business analytics for management decisions, where we have discussed all these details. The first 2-3 chapters are more or less same, because these are all basic requirements for any kind of econometry modeling and analytics. So still I am highlighting all these things because it is the requirement of engineering econometrics. So that means ultimately for hardcore modeling, so first 1 to 3 chapters are the basic inputs or the basic infrastructure for hardcore modeling. So that is how we are actually in the process to know all these details. And this is how the kind of another example. So it's a kind of tossing a die, and tossing a dice where we may have actually outcome like 1 2 3 4 5 6, and similarly like 2 coin, if you toss, and 2 dice if you toss, then you will find plenty of outcomes. So that means in real life situations you will find different kind of interactive kind of issues, and when you are connecting each other, then the sample space will be actually enlarged accordingly. So you should know how is the particular structure, and how you can connect, and how to get the sample space, and how to get the event specific output, and then you can use this event specific output and the kind of sample space for your problem requirement and the kind of investigation requirement. See here, whatever I have already discussed, let's say this is a kind of day wise informations, and how you will transfer into probability format. So this is a day wise informations, and these are all frequencies. What will you do actually? You first calculate the cumulative frequency, and then divide the total cumulative frequency with each individual, then you will get relative frequency, and by default that will be your probability. And if you add all these individual probability, then ultimately at the end you will get total probability exactly equal to 1. So these are all actually event specific, and we like to report all these probability and check how is the kind of distribution. So that means the kind of flaws of a variables with respect to frequency, so that you will get to know that variable follows means what is the distribution this particular variable follows. So accordingly you can develop the modeling as per your problem requirement. Until unless you know the kind of distribution, you may not in a position to pick up a particular model. So that is how you have to know the concept of probability and the kind of probability distribution. So this is how the simple examples, and then similarly that is how what we have already discussed. So the probability range will be 0 to 1, and total probability exactly equal to 1. So this is two basic principle of the probability, and it is always true whether the problem is a very simple one, very complex one. And this is standard examples here, and dice sum, because if you are tossing 2 dice simultaneously, so first happening, second happening, and their sum, so it will start with 2 3 4. So obviously because dice is minimum number is 1, so if both will be having minimum, then the sum will be starts with 2, and then similarly 3 4 5 6 up to 12, because the maximum number of number in a die is equal to 6. So if both will be happening same times, then it will be total 12. So this is the all possible events, and that is what the sample space are all about. And then ultimately with the help of frequency you can find out actually probability structures, right? So this is how means total actually coming 36, that's the cumulative frequency. If you divide with individual, so then that will give you the event specific probability. So and on the basis of that event specific probability, you can check the distributions, how is the kind of distribution. Ultimately most of the instances will check whether the distribution is the normal one and not normal one. So if not normal one, what particular distribution, other distribution it follows. Like we have discussed in the very beginning, the functional relationship will be linear one and non-linear ones. If it is a linear one, the game is very restricted and very simple. So if it is a non-linear one, and there are different kind of nonlinear functions you may have. So again the complexity will start accordingly. So similarly the case of normal distribution and not normal distribution. So but usually most of the things, means in the case of normal distribution some of the things are very smooth and very streamlined, but in the case of other distribution it is not so systematic. So ultimately a econometrics environment is like that, if you increase the sample size and restructuring, most of the distribution can actually converge to normal distribution, and ultimately most of the instances we do all these iterations or the kind of restructuring, ultimately try to bring in a kind of setups, maybe normal completely normally distributed setup, so that the particular investigation process will be very accurate, very effective, and will be very needful for the requirement. Otherwise it may be a kind of biasness, and you will not ultimately get the right answer, right output to address the problem. So that's why we need to do some kind of structuring, restructuring, normalizations. Okay, so increasing sample size, means there are variety of ways you can rotate the games as per your requirement. After that, if you are not getting, that means the problem may be dangerous or may not be handy to solve with the help of this particular engineering econometrics. So these are all basic concept, and in addition to that, some of the basic concepts like this is P a complement. So since total probability is equal to 1, so probability of happening, not happening. So if probability of happening is available, by default probability of not happening you can actually get. So that means it has a some kind of beauty, because some instance of missing observations are there, but now with the help of this concept of probability or the rules of probability, you can fill up this missing observations very easily. And these are all various rules of the probability, and I am not going in details. Again, so sometimes if there are two events minimum in a particular setup, if it is only one event, then the game is very simple ones. Then the game plan will be start in a complex way. So when the events are more in numbers, and the issue is that let's say there are two events A and B, that's the minimum number of complexity or minimum level of complexity. When A and B is there, so A and B may be actually completely independent, or there is some kind of commonality is there. So that's why you need to know some kind of rules of the probability, how you have to bring the kind of situations. For instance, if A and B is there, then the probability says that what is the probability of A where B is not there, what is the probability of B where probability A is not there, and there is a chance that probability A and B simultaneously are there. So that means both can actually very handy to represent the particular specifications. So all these details are there in the theory of probability, and these are all the kind of requirements against for the engineering econometrics, and that too inferential econometrics requirement. So these are all various examples, like whatever examples I have cited, and this is little bit more complex kind of an example. Again, like variance covariance matrix, we can create a probability matrix that will give you better pictures actually with respect to more number of features, more number of variables. Means the thing is that it's a very interesting kind of concept and very useful for modeling. Once your problem is very much clear, clean, and understood properly, then you can actually process it as per your requirement, and probability will help you a lot to do the kind of needful. So this is another way of highlighting the concept of probability. It's called as cross tabulation mechanism, and this is what actually another way to find out the kind of issues or address the problem. Sometimes what happens, the joint occurrence is there and a particular event outcome is there, the other one is missing. Now with the help of this particular concept, we can actually find out the missing observations or missing requirement. So the particular property is called as the structure of Bayes theorem, and with the help of in this particular theorem, the understanding is that what is the probability of A given B. It's like what we have already discussed the concept in the case of partial correlations and the kind of multiple correlations. So in a real life scenario, it's a very very less instances you will find the particular event or the particular variable is completely independent. So most of the instances you will find the variables are actually behaved positively or negatively in presence of other variables, or the other variables, the behaviors or the impact may be like pull or push, but ultimately it is the kind of a requirement to connect and check the kind of issues and the kind of solutions. Until unless you connect, check and address the problems, you should not actually proceed for the hardcore modeling. So these are all basics you have to remove. That means in every stage you need actually neat and clean environment before you go for the kind of hardcore modeling. Until unless you have clean pictures, so you may not actually estimate, means starting with choice of the models, estimation of the models, validation of the model, use of the model. So some point of time it will give you some kind of problem. So that's why it's better to clean all these things and know all these things before you enter to the big battlefield. So likewise, the Bayes theorems can be actually simple and can be also in a complex framework. So that means ultimately what I have mentioned, you start with a simple one, then add one after another, then the level of complexity will start increasing. And like we have already discussed in the case of bivariate setups, so the concept of probability is also similar way. So they are not different, but the structure is slightly other way around, but ultimately the major goals or the kind of objectives are more or less concentrated towards the investigation process, that to how to get some kind of empirical evidence to address the particular engineering problem. These are various examples again, and I am just skipping these ones. And then ultimately next item is actually the probability distributions, and for that you need to know random variables. And the random variables means variables which will be randomly just means outcomes are somehow not actually very specific, means there is biasness ultimately. And the particular structure can be continuous, can be a discrete, and then that itself will give you the understanding about the probability distributions. We have a different kind of probability distributions. Let's see what are the distribution and how is the particular functionality or functional forms, and how is the kind of requirement. Sometimes depending upon the particular problems, you can apply a particular distribution. Sometimes once you understand and once you know the structure of particular distributions, you can easily actually connect and looking for the kind of inference. So these are the classic examples of discrete variable case and continuous variable case. For instance, outcomes of dice rolls, whether a customer likes or dislikes a product, these are all called as discrete variables examples. And the examples of continuous variable is weekly change in DGI, daily temperature, time between machine failures. So these are all continuous variables. There is a need of continuity or some kind of consistency. That's what and it has a very big link with time series data, and that too with response to actually the kind of cross sectional kind of data. So the continuous variables, if you talk, that this is very familiar with time series structure. and this is what actually another way of understanding. And once you know the total outcomes, then the kind of event issues, so you can create your own probability structures, and you can check the or you can design the probability distribution. Just you can visualize, then ultimately you can get to know how is the kind of distributions, whether it is a normal one or the other way around. So this is how this is how a kind of distributions, it's not exactly normal but somehow close to normal, but ultimately this is how this shaping. And sometimes what happens, some of the cases you cannot just manipulate data, or you may not have options to do the kind of transformation or something restructuring, but ultimately you need to have a balancing, and one way to in such a situation, one way to solve this situation is increase the sample size. Actually, somehow if you increase the sample size and slightly normalize, then ultimately the distribution will move from means closing towards normal distributions. So ultimately normal distribution, since normal distribution is the best, ultimately we try to structure so that the particular data structure and sample space will be normally distributed, and as a result you can easily pick up a technique to address the problem. This is another way of distributions. And usually probability distribution, if you talk about probability distribution, so that means there is a random variables corresponding, it has some kind of event specific, and then corresponding to each event we must have a probability. For instance, the simple structure of understanding is lex is a random variable which carries events like x1, x2, x3 and so on, and the corresponding probability will be p1, p2, p3 and so. Now the question is how you are getting the probability, so that depends upon actually a particular distribution. So it depends how is the kind of shape and structure, but whatever ways you can address, so ultimately the probability value will be in between 0 to 1 and total probability exactly equal to 1. That is why we have written here. And this is like same case like correlation, whatever ways you can handle simple, partial, multiple, then ultimately the range will be between -2 to 1, and means it is a kind of structured framework, or what we can call as a standardized framework, so that it's very easy to address, easy to understand and easy to actually use for the kind of requirement. So that is how the simple structure of probability distribution. And then what is happening actually, you can just design the probability requirement, then you plot. After plotting you will get to know the kind of distribution. This is what actually cumulative distribution functions. And this is another example called as say we have actually descriptive econometrics where we have discussed central tendency, dispersions, and kind of bivariate econometrics like covariance and correlations. Ultimately here is also case having actually variables and the corresponding probability. So you can also touch upon all these components again and get to know how is the kind of series all about. Ultimately the difference between these two is sometimes when you have a variable information, say x1 and x2, x3, x4 like this, and they have no connection with probability, and sometimes they have a connection with the probability. It depends actually. Most of the future predictions where the probability attachment is always there, but when something already happened and you have collected something else, so there is no need to actually connect with probability. But whatever may be the wedge, whether it is a simple structure or probability structure, ultimately the game is exactly as per the particular requirement. So you can plan accordingly and then use as per your engineering problems need or applications. So these are all various examples, and this is called as discrete probability distributions. And under the discrete probability distributions we have a couple of distributions, and this is the simple example of airline revenue management. and here we have actually x variations and corresponding probability. Then you can get to know what is the mean flaws and variance flaws. All these details you can have, and then you can address the problem. And this is how the variance can be. All these are same like whatever we have discussed in the case of first two lectures, and that to the descriptive econometrics with one variable case and two variable case. And one of the discrete probability distribution is called as a binomial distribution, so where the structure is like this. P is the probability of success, and its counterpart is called as failure, which is nothing but 1 minus p, and that is how we will transfer. And this is very very much required in the case of econometric engineering econometrics, where we will use some of the typical or structured kind of molding. So like logit molding, probit molding. In that case, we will need this particular distributions. So these are specific examples of binary or binomial distributions, and here you need to have some kind of specifications, and the distribution will be like this. NC x p to the power x 1 minus p to the power n minus x. This is what the functional form. Either the particular variable will follow that functions or not. This is the kind of examples. Ultimately, all kind of distribution, we have a parameters and the kind of random variable. So you just specify. Ultimately, it will give you the indications. Ultimately, we can use the Excel spreadsheet to get all these numbers. Excel spreadsheet has a such kind of functions. You can easily get all these things. Just generate the kind of requirement, and then ask the software to or spreadsheet to report the particular items. Ultimately, you will get it. So this is actually 1 minute's job, but ultimately you need actually understanding. So this is one kind of classic example. Similarly, we have a different kind of. So this is how the procedure through which actually you work in the Excel sheet. So for a binomial distribution, the following command you have to give only. Then ultimately, for a particular random variable x equal to 3, and your actually the requirement n and p you have to specify. Then ultimately you will get actually this is a p requirement, and this is the n requirement, and this is the trials. Then ultimately you will get to know what is the probability value. This is ultimately this value will coming under same 0 to 1, but the functional forms are different. So this is how the typical examples. And likewise, so we have similar kind of distribution you can check after plotting. And this is another kind of discrete probability distributions, where we have actually a functional from e to the power minus lambda to the power x by expected. This exponential functions. And ultimately, again, some of the engineering econometrics models, we need these distributions to solve some of the engineering problems. Ultimately same. So you need parameters value and the random variable specification, and again ask the software to report these variables. So these are the instances you can use actually a Poisson distributions, and ultimately is a same the Excel function will be like this, and you get to know whether it is actually normally distributed or not normally distributed. And likewise, so these are all various cases. And in the other sides, the continuous probability distribution, that's called as normal distribution basically. So under normal means continuous case, the probability density here you need a kind of confidence intervals through which you can actually project the particular outcomes. So starting with uniform distributions, then same the mean reporting, variance reporting, then these are the classic examples of uniform distributions. And okay, so I am just skipping because ultimately these are all not our requirement. Just I will get to so I like to highlight these are the various distributions are available in the probability theory, which is actually one of the requirements for our engineering econometrics modeling. And in the normal distribution, this is one of the highest distributions, or distribution at the highest levels, where most of the engineering econometrics problems can be solved through this particular distributions. And here the parameters are mu and standard deviations, and by default x is the random variables, and the variable will give you snapshot, very simple kind of conclusion, symmetric or non-symmetric, and where means few properties are mean, median, mode will be coincide, and it's completely unbounded games, and empirical rules easily can be applied, how you have to work out this particular so that means when in infinite kind of range, so it's very difficult to work out. So in that context, normal distribution will be very handy to solve this particular problems. Like when this is the typical structure of normal distributions, and like Excel spreadsheet, you can just put normal distribution and give the random variable indications and the parameters values, mean, standard deviation. That's the one of the means, these two are major indicators of this normal distribution. Then ultimately you get to know the probability value. So again, whether it is a binomial distribution or Poisson distribution or normal distributions, the range of the probability will be 0 to 1, and the total probability will be 1, depending upon the sample space and the kind of event specifications. So likewise, there are different instances altogether, depending upon left skewed, right skewed, left attack, right attack kind of things. And okay, so these are all ultimately means this is another kind of exponential distributions, and again it is one of the basic requirements of engineering econometry modeling, which will be used in the later stage. And so that means technically, again these are all additional different distributions, log normal distribution, beta distribution, triangular distribution. Ultimately the point is that before you start for solving any engineering problems through engineering econometrics, so again this what I every time representing that these are all basic infrastructure actually for this engineering econometrics investigation. So you must be acquainted with the probability and various distributions associated with the probability, with simple structure and complex structures, and depending upon your engineering problems, you have to check whether the particular problem is connected with a particular distributions, and then you have to develop the models and look for the solution as per the particular distribution only. So with this we will stop here, and in the next class we will discuss the details about the sampling and sampling distributions. Have a nice time, and thank you very much.